Today we will be discussing some more problems on one-dimensional arrays. To start with, we will be first seeing how to store n random numbers in an array. So let's move into our directory first. Now let me create the first file. So I want to work with random numbers. So random arr.c, let's call it. Now what I'll do here is I'll first create an array comprising of n random numbers. So in order to do so, first thing I need to do is I have to include the stdio.h. So insert hash include stdio.h. Let me increase the font size even more. So next, after that, I will require to define the size of the array. So that's it. Then int main. Okay, inside the main function, what I'll do here is I'll consider creation of an array of size 10. So I will need a loop variable here. I will need an array of size 10, and then I'll need a variable r who will be storing the random number. All these 10 numbers that we are just going to store over here, they are going to be randomly generated. So for that, I will start with the loop first. So for I equal to 0, I less than 10, I plus plus, and inside the loop I am going to generate the random numbers. So firstly, in order to generate a random number, we write something like we call the rand function, and then let's say that we want the random numbers to be in the range from 0 to 10. So in order to do that, we are giving this modulus operation here, and then we are giving the value 10. So this is what is this going to do? The random number, whatever is generated, that will be divided by 10, and whatever is the remainder, that will get stored in the variable r. Now random number that will be generated when we do that modulus 10 operation, the remainder is always going to be less than 10, so we can expect values from 0 to 9 to get stored in the variable r. Next, what we will do, we will store this inside the array. So arr of I, so in the ith position of the array, we are storing the random number r that has been generated. So this completes our storing or creation of the array with random numbers. Next, what we will do, we will consider displaying the array. In order to do so, again we need the for loop. Then we will simply write a printf statement, printf \t %d comma arr of I. Note that since we have got only one printf statement here inside the for loop, so we don't need the curly brackets, and in between the numbers taken as input, I'll just add another printf statement just to give a good look and feel. And with that, we all need to do the last step, that is the return 0. Saving and quitting. So gcc random array.c -o rand arr. Okay, so this rand function is basically given in the header file stdlib.h. So I think I have missed including that. So here I have got an error stating that implicit declaration is not there. So what I have missed is I haven't included the stdlib.h. So let me just include the stdlib.h and recompile that. And then there it is. Now that we have compiled it perfectly fine, let's execute the executable file that has been created. So you can see here the random number that is generated here is 793802. Reduce the screen size, and here you can see still 10 numbers are not coming. It's not visible here. So what I'll do here is, instead of giving the \t here, I'll just give a \n over here. Now the numbers are going to come one after the other. So I'll just compile it, run it once again. So you can see the random numbers have been generated. Now there is a very interesting aspect of this thing. See, even if we compiled it multiple times, whenever we are going to run it, we are going to get the same set of random numbers. This is because of the something called that is seed value. So a seed value ensures that the random numbers that are being generated, no matter how many times I execute this program, it's going to be the same value. So there we have got the values. Hence, rand is called a pseudo-random number generator rather than a random number generator. Now, the second problem that we will be working on is displaying the mean of these numbers. So, let's open the program once again. Now, our job will be to calculate the mean. So, after we have displayed the array, next what we will do is we will simply calculate the mean of these numbers. So, in order to calculate the mean of these numbers, we need to calculate the sum of these numbers. So for that, I'm introducing here another variable by the name sum, which is initialized to 0. Now when we are trying to calculate mean here, what we need to do is we need to run the loop once again, and we need to identify the values that are stored in each and every cell of the array, and then we will be simply adding it up to the variable sum. So for that, here I write sum plus equal to ARR of I. This is going to find the sum of the numbers, of sum of the 10 numbers, and that is going to get stored in the variable sum. Next, what I need to do is I need to find the mean of those numbers. Now, mean can be a floating point number because when we are performing a division operation, we cannot always guarantee that the number is going to be an integer. So, float mean. And then what I need to do here is, in order to calculate the mean, I have to first explicitly convert sum to a floating point number because sum is an integer, and then I'll be dividing it by the variable with the value 10. So mean is going to be equal to float of sum divided by 10. Okay, finally display the mean. So printf that's it. So let me just compile it and see. That's it. So when I compile it, it's perfectly fine, random arr.c, and then when I run it as rand arr, I get the mean as 5.3. The mean array is this and the mean is this. Next job will be to find the highest and the smallest number along with their positions. So let me reopen the file once again. So my job will be next to find the highest and smallest. So in order to find the highest and the smallest number, or the largest and the smallest number, I need two variables, or rather four variables, who will be holding the values as well as the position of the largest and the smallest number. Let the variable who will be holding the largest number be LAR, and the position be held by LAR underscore pose. Then smallest number be held as SM, and the smallest number's position be held as SM underscore pause. So initially what we will do here is, when we try to find the highest and the smallest number, we will assume that the value in the first cell is going to be the largest as well as the smallest number. So LAR is going to be ARR of 0. Similarly, SM is going to be equal to ARR of 0. Then LAR underscore position is going to be equal to 0 because we are talking about the first position of the array, and SM equals to SM underscore pause is also going to be equal to 0. Now what we will do next, we will traverse the array to find the largest and the smallest value. Now since we have already considered the first element of the array, we will start traversing the array from the first position, the 1th position. So I less than 10, I plus plus. Now if I somehow find that the value in the ARRI position is going to be higher than the LAR value, I'm going to update the LAR value and its position. Otherwise, I'm going to, if it is smaller than the SM, I'll be updating the SM as the SM position. So if I find that the value in ARR of I is greater than LAR, that means this is going to be comparatively larger than the LAR. So here I'm going to update the value of LAR. So LAR is going to be equal to ARR of I, and LAR underscore pause is going to be equal to I. Okay. And similarly, if I find that if ARR of I is less than SM, that is the smallest value rather, in such a case, I will update SM as equal to ARR of I, and SM underscore pause as equal to I. So this loop is supposed to give me the highest number and the lowest number. Finally, I'll just give a printf statement where I need to display \n largest number is %d at position %t and smallest number is %t at position %t. So here I'll give lar underscore pos sm comma. Fine. So I'm displaying that. So escape wq. I've saved it. Now let me recompile it. Recompilation done. Next, what I need to do is I need to execute it. So it's giving that the largest number is at position 1 and the smallest number 0 is at position 4. So 0, 1, 2, 3, 4. So smallest number 0 is at position 4. That's perfectly fine. Largest number 9 is at position 1. That is also right. Why? Because the moment we have found the largest number as 9, when the comparison with the last element happens, we find that this 9 is not greater than this 9. So the condition that we had given in the over here is that that if the array value happens to be larger than lar, greater than lar, it's only then it's going to get updated. But in this case, what we have found is it is equal. That's why it is not updated. So in one way, yes, we are getting the correct answer. Okay. Since we have considered mod 10, automatically the numbers are going to range from 0 to 9, and since we have got only 9 slots, chances are high that there will be collision. So in order to avoid this, what we can do here is, instead of dividing them by 10, let us divide them by 100. I think we have got a unique set right now. Okay. So after giving modulo 100, we have got the unique set of numbers. The highest number here is given as 78, which is in the position 7, that is this one, and the smallest number is 7, which is given in position 0. So yeah, we are getting the largest number and the smallest number. Next, what we will do is we will look forward to swap the largest number and the smallest number. So now that we have got the position of the largest number and the smallest number, they are given in large pos and small pos. What we will do is we will simply swap the values that are there in the large pos and the small pos. So for that, I'll add another module over here. So what I'll do here is I'll just consider a temporary variable. Of course, we can always do it without considering the temporary variable. I'll leave that as an assignment for you. You can just go and do it without considering the variable, the extra variable or the temporary variable. So, but I'll consider a temporary variable here. So let's temp. So what I shall do here is, when I try to swap the largest and the smallest number, firstly we have to find the position of the largest number and the smallest number. So we have already done that, and now that we already have the answer to that, what I'll do here is I'll just consider temp is equals to ARR of large pos. ARR of large pos is going to have the value equal to ARR of small pos, and then ARR of small pos is going to have the value of 10. So that should swap the values. Next thing what I need to do is I need to display the array once again. So escape :wq, I'll just save it, and then I'll compile it again and I'll run it again. So what do I get here? See, this is the initial array. Initial array is something like this. So we have got 78 here, we have got 7 here, and the mean is supposed to be this value here. We have found the largest number at position 7, which is this one, and the 7 smallest value is at this position, and then we can see that those two values are both swapped. Okay. So this is the first assignment that I wanted to discuss with you. Insertion and deletion in the array is what I'll look forward to. So insert underscore delete from array.c. Insert delete array.c. In this example, what I'll do is I'll just consider one array of n numbers, or in this case let's consider 10 numbers, and then I'll look forward to insert a new element in the array, and at the same time we will see how we can delete elements which are already there inside the array. So I have already created the file, and let's open it. And now the first thing that we have to do is we have to create the array. Okay, so we have to first create the array. So the first few steps are going to be as before. So, and then I need some more variables. This variable pause is going to mark the position where the new element has to be inserted. And then I need another variable num, which is going to take the new number that we want to insert at position pause. And yeah, that's what we have for now. So initially, what are we going to have? We are going to have, say, an array of having only 5 numbers. Of course, we need to allocate larger space, because when we try to insert numbers, we should have that space available with us. If we don't have the space, we cannot go on inserting numbers. So how many numbers are going to be there in that array initially? That is again what we need to take the value as input from the user, and we need to store at that many number of values. So here let us consider the value to be n. So I'll simply ask the user to provide the value of n, and which of course has to be like less than 9, because if we have, the array has got only 10 cells. Okay, so only if we have got 9 cells, we have got the scope of adding one more element. So the values, the initial number of values in the array should be less than or equal to 9. So, or enter the number of initial number of elements. So enter, that means how many values are already there or which will be there in the array before the insertion process starts. So let's consider that value that is being provided by the user as input. So scanf %d, comma, and %n. We are storing it in the variable n, and n of course has to be less than equal to 9. Only then this is going to work. So if n is greater than 9, then this is not going to work. So what I'll do here is I'll put a constraint here. So I'll just check, like, do this job, and this is where we're done until n is less than or equal to 9. So if while n is greater than 9, then this is going to be repeated. So if n is greater than 9, if I give a value as 10 or something, that means there will be no space left in the array. So obviously that n, we cannot proceed with that n. So we are giving a loop over here. So until and unless the user gives the value which is less than or equal to 9, we will ask the user to go on providing us with numbers. Okay, this is one way of checking the values. Next, what we will do here is we will simply store the values in the array. So for I equals to 0. Now that we know that we have got n elements, so I less than n, then I plus plus. So I'm going to take the values as input from the user. But why? I need to inform the user that next you have to provide the values of the array as input. So printf \n, enter values for the array. Okay, so I'm giving another \n, so that's it. Now here this for loop is going to be responsible for taking the values as input inside the array. Now this is the initial array that I have created, so I'll just display it once again. So for I equals to 0, so that's it. So I'll just write one more statement here. So now I got yet to see in the array that I have already created. After this, what I need to do is I need to go for the new value that I have asked the user to provide, and that one that I want to insert in the array. So position where it has to be included and the value. So printf enter new value and position. So two values are going to come. So 2%ds here. First one is going to be the number, so ampersand num, and the second one is going to be the position, so ampersand pause. I have got the position as well as the number. Next, what I need to do is I have to shift all the elements from the pause +1 position onwards to the right by 1 position. So this is where the trick comes into the picture. So what I'll do here is for I equal to n. So you see I'm going backwards since I already have n numbers in the array. So for I equal to n, I am initializing I as n, and then I greater than equal to pause I minus minus. This is a new loop I am starting, and inside the loop what I'll do here, the objective of this loop is to simply just shift the elements by one position right. So what I'll do here is ARR of I plus 1. So you can see that initially this I plus 1 is going to be the n plus 1th position. The n plus 1th position we haven't used, or we haven't stored any values yet. Our values are stored till the nth position. This is the nth position. So here you can see. So here we are starting with I plus 1th position. This is going to hold the value of ARR I. So we are just copying the values one place right. Okay. After this, what we will do, we will simply just consider ARR of pause equal to now. So this is going to this loop is responsible for shifting of the numbers. So I'll just put that. So the array has all the new number has already been inserted. Now what I need to do, I'll just simply display the array once again. A return 0 will do the job. So let me save the code. Let me compile the code. GCC insert minus o in underscore del. Okay, I have missed a semicolon, so I have to give it executed. So dot slash in underscore del. So initial number of elements, let's consider that there are 5 elements in the array. The values of the array is 1, 2, 3, 4, 5. So this is the current array that we have. Now we will be providing the new value that we want to insert and the position. Let the new value be 40, and let the insertion position be 3. Now which one is the 3th position? So 0, this is the 0th position, 1th position, 2th position, 3th position. So I am supposed to have 1, 2, 3. Then in place of 4, I am supposed to get 40, and then 4 and 5 should come after this. So see, that's what we have got. So 1, 2, 3 we have got. And in place of 4, this 4 wherever it was, instead of that I have now got 40, and then 4 and 5. Now if we want to see the state of the array at every step after the shift operation, so what we need to do is when we are trying to shift the cells, or we are trying to copy the cells from one position to another, I'll just display the content of the cell once more over here. Okay, so here we are trying to shift the cells by one position. So here I'll just consider giving one more. I'll just loop over here. I'll give here. So let me consider another loop variable. So here let me consider it as j. So what I'll do here is I'll initialize as j equals to 0. Sorry, j less than n plus 1, because we are going to have one extra now, and then j plus plus. And inside this I'm going to display the content of the array. So printf backslash d instead of backslash d, let me just give 2 spaces or 3 spaces and then %d, and then I'll write ARR of j. So this is going to display the array while the shifting is going on. So I'll just write another printf statement before this. So compiled it, running it. So initial number of elements, let it be 5. So 1, 2, 3, 4, 5. Now asking for the new value and the position, let it be 40, and in the position say 3. Okay, so what one problem is that I will just need to give the backslash n. So I'll just open it once more, and here after this for loop gets executed, I need to give one backslash n. Why? Because otherwise the content is not going to go to the new line. So printf backslash n here, just to bring the content of the array after every shift operation in new line. I have given this backslash n. So gcc dot slash, now 5 elements I'm going to give. So 1, 2, 3, 4, 5, done. 40 in the position 3. So you can see here what happens. These are the initial elements that we had. Okay, now when we are trying to display it till the 6th position, or the 0, 1, 2, 3, 4, 5, 5th position. So this has got a garbage over here. Next, what happens, this value gets copied into over here. So here you can see the common values are there. Next, this 4 here, this one gets copied over here, and then this value is replaced by the value 40. Let's run it once again, and let's have 5 elements. Let the values be 1, 2, 3, 4 and 5, and let's say I want to add a new value, say 100, in the 0th position. So in that case, you can see here right at the beginning we have got this one as garbage. Next, this 5 here, this one gets copied. Next, this 4 gets copied. Next, this 3 gets copied. Next, this 2 gets copied. Next, the 1 gets copied, and then this one, in the next step, this one gets replaced by the value 100. So that's how we perform insertion in an array. Now let's move on to consider deletion from an array. So if I want to delete a number from an array, so I'll just consider that the same values, that is the num and that I want to delete, and the position from where I want to delete. So I'll just ask the user which value and from which position you want to delete. So printf \n, enter position whose value you want to delete, and then I'll store that here in scanf %d, comma, and %pause. Now pause holds the position whose value I want to delete. Okay. Now when I want to delete the value, what will happen again? That value has to get replaced by the subsequent numbers, and the value number by the number of elements in the array, that is going to get reduced by 1. So for that, what I need to do here is I'll just run a loop. So for I equals to pause I less than n I plus plus. So the position, we are starting from pause, and what we are going to do, we are going to replace this value with the value in the subsequent position. So ARR of I is going to hold whatever is there in ARR of I plus 1. So that means it is going to get replaced. And then what we need to do here outside the loop is we need to decrement the value of n. That means the number of values that are present in the array. Finally, if I try to print the array, so let me just save it, recompile. Okay, initial number of elements is 5. Values are say 1, 2, 3, 4 and 5. Array is this. New value I want to give as say 20, and in the position 1. So the shifting operation is done, and finally the insertion has also been done. Next, I want to delete the value 20 once again. So I'll give the position value which is equal to 1, and after deletion, see, ouch, I got the 5 deleted as well. So let me just display I equal to 0, I less than equal to n. Let's go $WQ GCC five elements initially. Number of values is 1, 2, 3, 4, 5. New value is 20 at position 1. I got the enter position as 1. Now I get the values. Now why did this error occur? Why did I have to go for this manipulation? Note that when I have performed the insertion operation, nowhere did I increase the value of n by 1. While printing the array after the insertion, what I did here is I have just considered n plus 1. I haven't changed the value of n. Okay. So what I should have done is, after I have inserted the new array in the new position, this one I should have done n plus plus. Okay. So finally, when I'm going for the deletion process, what I need to do here is I'll just consider I less than n this part, and here also I need to consider less than n. So this should do the job. Since I did not increment the total number of valid values in the array, that's why this issue cropped up. So I have 5 elements initially. They are 1, 2, 3, 4 and 5. Done. New value is 20 at position 1. Done. Now I want to delete the value in position 1. After delete, actually I'm getting 1, 2, 3, 4 and 5. So this is the second example. So we will stop here for this tutorial.